Hi, Mr. Richards here. Today's lesson is on translations and reflections on the coordinate plane. Our first step today is to take a look at the vocabulary we need to know in order to be successful with this lesson. Our first word is transformation, and a transformation is, first off, a movement of a geometric figure. And in detail, it maps an original geometric figure which we're going to call the pre-image onto a new figure called the image. And speaking of image, this is every corresponding point on a figure after its transformation. Now, with some transformations, we end up with congruent figures. And congruent will have figures that have the same shape and size. Now, in detail, what is a translation? This is when a figure is slid from one position to another without being turned. Next, we have reflection, and this is when a figure is flipped over a line, and that line is called the line of reflection. And so we have transformation, image, congruent, translation, reflection, and line of reflection. All key terms you need to know to be successful in this lesson. In our first example today, we have suppose triangle ABC is translated 4 units right and 5 units down. Find the coordinates of the vertices of its image. Well, our first part here is to rewrite the coordinates of the original. And if we were to do that, we would have our original here. And our original A is located at -3, 7. Our B is located at -1, 0. And our C is located at 5, 5. Now, something kind of neat happens here with translations. One way to translate a figure is simply to count. All right, I want to take my A, 1, 2, 3, 4 units right, and 1, 2, 3, 4, 5 units down. So we would expect our answer to be at 1, 2. However, there is a mathematical way of doing this. When we think about 4 units right, we're going along our x-axis. And if we're going to the right, we're going in a positive direction. So one thing we could look at is saying, all right, my translation here, I'm going to be going plus 4 for my x coordinates. My x's are going to increase by 4 because I'm going 4 to the right. And then for my y, this is 5 down. And so I'm going down, which means I'm subtracting 5 from each of my y's. So for each of my points, I can write that the translation is going to be plus 4 since I'm going 4 to the right, and minus 5 since I'm going 5 down. And actually I can, without even counting and graphing now, say, well, where is my image going to be? If I look at my new A, we did count that one, and we counted that, if you remember, at 1, 2. And if you were to mathematically look at this, negative 3 plus 4 is that 1. 7 minus 5 is the 2. And so that's where this ends up here at 1, 2 for that A. B, if we don't even count first, if we just look at our translation, our B, if I take negative 1 and add 4 to that, I get 3. And if I take 0 and subtract 5, that is negative 5. Now, on this graph, it kind of runs out of space here. So we'll need to draw in a couple more spots here. If we were to count this, B goes 1, 2, 3, 4 units right, and 1, 2, 3, 4, 5 units down, which puts me right here for my new B. And these are also called B prime. When you see that little dash there for A prime and B prime, it's our way that we mark our image. So sure enough, if we were to count our B 4 units to the right and 5 down, we end up at 3, negative 5. Or if we look at our x and add 4, we get the 3. And if we look at our y and subtract the 5, we get negative 5. So that works. And lastly, now we have our C. C prime. And 5 plus 4 gets me 9 for my new x. 5 minus 5 gets me 0 for my new y. And so now that takes me, I'm going to have to draw in another little line out here for our graph. It's going to take me out here to 9, 0 for the new C. Now if I were to count just to check that, if I go 1, 2, 3, 4 units to the right, and 1, 2, 3, 4, 5 units down, that is there at C. And so I can graph that image like so. So the key here is you can count and graph, or you can use math and adding to each of our x's, since we're going 4 to the right, and subtracting from each of our y's as well to get our new coordinates for the vertices of our image. Next, if we take a look at reflections over the x and y axis, we'll start with the x-axis. And of course, it's helpful to know that this right here is our x-axis. And if I just draw in our basics here and just drawing in a triangle, I can create an A here at 1, 1. I can create a B at 2, 3. And a C at 5, 2. And so if I write the points of this original here, A was at 1, 1. B is at 2, 3. And C is at 5, 2. Now, to reflect over the x-axis, what we can do when we're just using a counting method is to take our A and see how many spots away am I from the x-axis. Well, 1. And so I need to go that many away again and get 1 over here. And call that A prime. What about B? Well, B is 1, 2, 3 away. So then I need to go 1, 2, 3 down, which is here. And that's my B prime. And for C, it's 1, 2 away from the x-axis. So I need to go 1, 2 down there. And that's my C prime. And if we connect the dots here, there's the new image reflected over the x-axis. But let's take a look at what happens to our coordinates to see if we can find a pattern. Well, our A prime is now at 1, negative 1. Our B prime is at 2, negative 3. And our C prime is at 5, negative 2. Can you see a pattern here between the x's and the y's from the original to the image? Now, looking at our x's, those x's did not change. The x's remained the same. What did appear to change, however, were our y-coordinates. What is different about our y-coordinates? Well, here they were all positives, 1, 3, 2. Here they turned into negatives. In fact, it looks like they're the exact opposites. And so that's actually what happened. These are the opposites. So if we wanted to write a general rule for what just happened there, when we reflect over the x-axis, we are taking our y coordinates times negative 1. It's an interesting rule. Now, let's go back up top to our reflection over the y-axis. Let's draw in kind of a fun shape. For my original, let's have W at negative 3, 4, X at negative 2, negative 3, Y at 0, negative 2, and Z at 1, 0. We can go ahead and graph that. There's W, X, Y, and Z. And if we connect these vertices, our pre-image appears. Now this question asks us to reflect over the y-axis, and so I'll just shade in this y-axis as a refresher. That's our y-axis there. And so we need to take each point and reflect over the y-axis. And so Z is over here, so it means it's going to come over here. W is over here, so it's going to come over here. X is over here, so it needs to come over here somewhere. And Y is on the axis, and it's actually not going to move. So if we use the counting method to graphing, if we look at our W is here, and we are 1, 2, 3 away from the y-axis, so we need to be 1, 2, 3 away on the other side, which puts me here, W prime. We'll just work our way down the graph. Z is 1 away, so I need to go 1 to the other side, which puts me here. So there is Z prime. Y is on the y-axis, so it's 0 away, so it just stays there. So that's Y and Y prime are the same. And X is 1, 2 away, so I need to go 1, 2 away for X. And that's X prime. And now if I graph these vertices, we have the reflection of this image over the y-axis. Now let's look for our coordinates to try to find a rule. So we'll have W prime, X prime, Y prime, and Z prime. Now remember, when we reflected over the x-axis, our x's stayed the same and our y's were the opposite. Let's see what happens when we're reflecting over the y-axis. Our W prime is located at 3, 4. Our X prime is located at 2, negative 3. Our Y prime at 0, negative 2. And our Z prime is located at negative 1, 0. And if you study these ordered pairs, our y's this time did not change. The y's stayed the same. While our x's, from negative 3 to 3, from negative 2 to 2, 0 to 0 doesn't count, but from 1 to negative 1, these are all opposites. And so, to write a general rule for this, when we reflect over the y-axis, we're going to take our x-coordinates and multiply those by negative 1. So to summarize this, when you reflect over the x-axis, your x points stay the same, but your y-coordinates are multiplied by negative 1. When you reflect over the y-axis, your x-coordinates are those that are multiplied by negative 1, where your y's stay the same. Now let's see if we can apply those rules on this question. The vertices of figure MNOP are M, negative 8, 6, N, 5, 9, O, 2, 1, and P, negative 10, 3. Graph the figure and the image of the figure after a reflection over the y-axis. Well, let's first label this. We'll have negative 10, negative 8, negative 6, negative 4, negative 2, 2, 4, 6, 8, 10. We need to count by 2's here. And then negative 2, negative 4, negative 6, negative 8, negative 10, and 2, 4, 6, 8, and lastly, 10. Now, we're looking for a reflection over the y-axis, and it doesn't hurt too much, at least, to shade in or re-emphasize your y-axis. That way you know where you should be reflecting over. And then let's go ahead and graph this original image. our M is at negative 8, 6, which is up here. And that's the M. N is at 5, 9, which puts it here. That's the N. O is at 2, 1, right about there. And P is at negative 10, 3, which puts it right around here. And so I can connect the image like so. Now let's practice what we learned on the previous page. Here we're looking at a reflection over the y-axis. That means that our x coordinates are going to be multiplied by negative 1, and our y coordinates will be the same. And so if I write out my ordered pairs again for these original, M is at negative 8, 6, and 5, 9, O, 2, 1, and P is at negative 10, 3. So my image now, let's see if we can find these before I graph. My M prime, I'm going to multiply the x coordinate by negative 1 and keep the y. That would make it 8, 6. My N prime, negative 5, 9. My O prime, 2 times negative 1 is negative 2, and we keep the y at 1. And then P prime, negative 10 times negative 1 is 10, and 3 stays the same. Now, we should expect the M prime to be at 8, 6. And if we were to count, we are 2, 4, 6, 8 units away from the y-axis. And so we need to be 2, 4, 6, 8 units away on the other side. And if I graph that point, this is my M prime, and sure enough, where am I at? 8, 6. Where am I supposed to be? 8, 6. It's pretty cool. Now, let's just graph in the other ordered pairs. N prime is at negative 5, 9. And sure enough, if we were to check that, we're 1 and then 3, 5 units away, 2, 4, 5 units away. What about O prime? Negative 2, 1. Well, negative 2, 1 is right about here. And there's the O prime. And again, we can still check it. It's 2 units away, so I'm 2 units away. P prime should be at 10, 3, which is right about here. There's the P prime. And again, if I count just to check, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So it works perfectly. Connect the points of these vertices of our image. That was a little high, so I'll just make my dot a little bit bigger maybe. Close enough. So that's how you can graph the figure and the image after a reflection over the y-axis using both the counting method and our new rule. That is it for this lesson on translations and reflections on the coordinate plane. Good luck.